Let's understand Pyro Source workflow. Let's take a box and it's a polygon. So here we have Pyro Source node. So what it will do? It will scatter some points and it will create density attributes. It can be anything. It can be a temperature, fuel, burn. And this is not the only way of doing this. We can even use points from volume to scatter points, and we can use point angle to add attribute. And till here they are just points, and we have to convert this into density. So for that we have one more node, volume rasterize attributes. Basically it will convert points into volume. In previous video we have used VDB from polygons, so that was quick way of generating any volumes, and here we are scattering particles, creating attribute. After that we are rasterizing. The reason of doing this with points, we have more control. In some cases VDB from polygons can be worked, but in most cases this is more procedural approach. So end goal is creating a volume. It can be any approach to do that, right? So now let's create this. Cool, let's delete this. And here we will use simple geometry like box for testing purpose. And let me use Pyro Source over here. If I connect this, it will show some points. And these are the cube points. Here if I increase this, and you can see here it's a point of cube, because we have this keep input points mode on over here. And I have other options as well. I can use surface scatter, so it will just scatter on the surface only, but I want to scatter inside as well. So for that I will use volume scatter. And next I have particle separation. It will scatter particles based on distance. So if I reduce this, we will have lesser distance and more particles. And after that we have particle scale as well. So if I go over here, middle click, and you can see here we have P scale. And how to visualize this? For that, let me reset this. And to visualize this, I can use copy to points. And here I can use box to copy this on each point. So I can see here it's properly distributed. And this is the scale. So if I reduce this till 1, right, so it looks like box, but it's not. And if I reduce it by 0.9, you can see here distributed equally. And if I reduce this particle separation, you can see here, this is cool, right? And now if I visualize this, I have other options as well. So I can just click on this plus icon and I can add attribute over here. So here I will use density attribute, and I have this value as well. And let's visualize this value. So I can just go over here, geometry spreadsheet. I can just see density, p scale. So let me increase this. So these are both linked to each other. And let me keep this default. So now it's time to convert this into a volume. For that, we will use volume rasterize attribute. If I connect these, I have some parameters over here, and I have to just select that attribute. So if I go over here, I can just select this density attribute here. The most useful parameter is voxel size, and we will talk about this. So what is voxel size over here? If I reduce this, it will increase the quality of voxels. And now you can see here, and if I reduce this by 0.5, volume rasterize is copy stamping this each boxes on points, and that's what it's doing. Let me just make this default. So that's how it's generating this volume. But the main question over here is, how do I figure out which voxel size I should choose for this one, right? So if I just view from camera, then I can see it's really in distance. And is this voxel size enough for this one? To figure that out, here we can see that this is the basically a voxel size as well. Now if I visualize this, I can see this is the voxel size if we keep this 1 over here. And if I reduce this, you can see here, we can just understand this as a pixel. Is this pixel enough? No, it won't. So we have to reduce this more, right? So you can see it's really tiny over here, and this is still not enough. We can just even reduce this even more for this distance. right? But if I reduce this to 001, then this is really high. So in most cases 005 is fine for this distance. But as you can see here, that every time we cannot just place this box over there and visualize this, right? And what if this box is in that direction? So let me just move this in that direction, right? So if it's in really distance, then how we can just visualize that? So for that we can just calculate center of this point, and I can just copy stamp there, and here we can use peg geometry. If I connect this, I will get one single point, and I can just visualize this as well, right? If I use copy to points over here, it will just place there. And now if I reduce this to 0.1, right, now it's really easy. If I place this anywhere, it will just follow that. So for this distance, this tiny point is fine. And you will understand this more when we actually simulate this. For now, let's just reset this and reset this as well. And next we will talk about top network.